today's call, this is actually kind of interesting. And I made no bones about it inside of the invitation. I like to be very transparent about these things. This is it's a 301 discussion, and I would say it's probably a very proper 301. To be quite candid. This is we're going to be talking about kind of some of the fundamental parts of the end user compute architecture. And while some of you may be focused really on the sales side, I appreciate you taking the time to jump in today because, I think that there's a value in stretching ourselves a little bit, especially when it comes to something as fundamental as VDI. I never thought 8 years ago that I would be saying that virtual desktop is a fundamental idea, but it really is. And, when we talk about, competitive positioning or, I'm thinking about going this way, I'm thinking about going that way, we often revert back to, well, VMware's better, or ours isn't as complicated, or, well, this costs this much. Okay, well, that's great. But then that's only going to take you just so far in the conversation. And number two, I'm a huge, opponent of kind of slinging mud. Right, I don't believe in giving anybody any airtime unduly, even if it's just to say that theirs does this kind of thing, right? Whenever possible. So, I believe that here we're going to be talking about some of the ideas as to why is the Horizon architecture so cool. And today we're going to be focusing just on virtual desktop. And I want to level set and say that the expectation for anyone here who is not an engineer, and you all know who you are, is not to memorize this stuff, but just to scribble down some notes and have some good fodder for additional conversation so that you can go, yes, I remember this is kind of how that works. And that is enough to make you even more dangerous and leverage you even further into that role of being a trusted advisor.
Okay, sure. Thank you.
So, number one, kind of take a look at the high-level agenda. We're going to be looking at the architecture at a basic, perspective, and then we're going to get into this idea of pods and blocks and some of the basic, calculations around memory and I/O and link clones, etc. And then ways to talk about application deployment, right? And ways that customers can optimize. And then also we're going to take a look at the end as to why, PC over IP, you guys have heard this, right, before. Why is that better than what else is out in the market, right? And why is it different? And what I'm going to ask of you, those of you who have seen me, present live, this is no different. I'm going to ask for audience participation, so, kind of give me some feedback. You'll hear a pregnant pause, as I progress. Jump in there and ask a question. Okay. So first things first. So this is Horizon View architecture at about 30,000 feet. Right? What you've got is right here inside of your data center, you've got servers. You got a little bit of background noise. I think *6 will mute your line if it seems noisy where you are. So you've got your servers here, right? And they're running vSphere. Okay, all right, all good. Okay, so now what's going to happen is you're going to have one primary component, and this is really important. This is a view connection server. That is the broker. Realistically, if you had a proof of concept, the proof of concept could consist of no more than just a vCenter server and a view connection server. That is enough to stand up a proof of concept environment for Horizon View. That's it. So it's pretty straightforward. Everything else here is an additional feature. We talk about the integration of a view security server. View security servers are there because they serve a very, very special purpose. What happens with a view security server is it accepts information on only two ports. Those two ports are 80 and 443, right? The two HTTP ports. But what it does is it transmits information back to the connection server on the 5 different ports that the connection server needs to listen to. So what does that mean to a customer? Well, what it means is when they're talking about setting up like a WAN accessible, internet accessible type of access to virtual desktops, that we have an out-of-the-box solution using the security server that allows them to do so without tons of complexity in their configuration. The security server takes care of it all. And the beauty of it is that it's all just one binary. What that means is that there's one installable file. You install that file on one virtual machine, and that becomes your connection server. And then you install it on another virtual machine, and that becomes your security server. And then your networking guys can put it inside of the demilitarized zone and all that kind of stuff, the DMZ, as they see fit. And you just pair the security server to the connection server. You say, who's my broker? Well, I am, and then off you go to the races. So this is pretty straightforward architecture, right? And we're going to be looking at what happens when we integrate things like View Composer and what that means to our storage. And this is important. Whether you're an engineer or you're a sales guy, why? Why would, at the beginning of the sales cycle, you want to start planting seeds about things like Composer or whatever, or linked clones? Well, simply because that means that when it comes full circle and you're having a conversation about storage, that you already know where their hearts and minds are, and you can make the correct recommendations and get the engineers and the architects and everybody down the right path of what this customer wants. The more we know and the more we have vetted, as soon as possible, the smoother all of these processes go. All right? Today we're not even going to be digging into Workspace or ThinApp too much or anything like that. We're just going to focus on what happens. How do we get desktops from out here, and how do we get them the right number of machines here and the right amount of storage here? And how do we start those conversations? Any questions on this one before I go forward? Okay, cool. So now we've got our high level. And remember, one connection server is all you need for proof of concept. Now, we take this and we're just going to scale this architecture up a little bit. Remember our connection server, right? We had our connection server. Our connection server lives right here. So we've got that connection server. What we did was we just deployed another one. One becomes the master, and then they just say, okay, well, who am I? I am a replica. Okay, well, where's the master? You point them over there, and they go, oh, okay. And what's really neat is they start sharing what's called an Atom database. So they start sharing this information back and forth between each other. Even though they're not like load balanced, they're sharing information so that if one of them dies, what happens? The other one just picks right up, keeps going. So now this is redundancy. And remember what I said? It's just one binary. So they're talking about going out with one executable file, one ISO, and they can deploy all this. So now what about those security servers? Well, the security servers are right there. And remember we said you're going to pair the security server with the connection server, because the security server is the one that listens on 2 ports and translates it into the 5 that the connection server needs for security purposes. So the security servers act the same way. They too will share information. Now you've got customers who access from maybe a tablet or a kiosk or whatever. They're going to hit, let's say, view or horizon.techdata.com, right? Okay, cool. So they're going to hit that, and then that's going to take them to their load balancer. Their load balancer will say, well, which one of these should I go to? And then that puts them right back there to the connection server. And then they get their desktop provisioned, and everything comes right back to them. So what you're looking at, even though it seems pretty high level, This is the premise for a highly redundant virtual desktop architecture. This is why it's not as complex as everybody makes it. Now, it is very detailed, but it doesn't have to be complicated. Okay? Exceptionally detailed, but not necessarily complicated. One of the things we were talking about, PC over IP, and you guys see this, people have seen this on the marketing stuff. PC over IP is actually technology that was developed by Teradici years back. And it was originally just kind of a hardware type of technology. Using PC over IP, what we're able to do is take that connection for that customer or that user right from that security server, and it can leverage and ride PC over IP all the way back into the infrastructure. And it uses the same kind of methodology. Listen on 2, translate back to 5, right? So everything is secured. And then it just jumps on there, and they get their stuff securely. So now if we're looking at this, how do we decide what do we need as far as, how many of these connection servers do we need, right? How many vCenters do we need? How many composer servers to do the linked clones that impact the storage? How many of this does this need? How many people would this picture right here support? Anybody want to take a guess? I know somebody out there has to have a guess. I'm gonna pick a name if nobody guesses.
I guess 30.
You guess 30. 30 people. Okay. This architecture right here would actually support about 2,000 users.
I was close.
No, but that's great. And that illustrates the point that what we're looking at here is so straightforward and it's super scalable. So now let's talk about how do we multiply this for something really big, like 10,000. Okay? So this is where we get into this idea. Remember we talked about connection servers? Okay. So now picture in your mind what you just saw a moment ago on this slide, the connection servers and the vCenter and all of that. We got this idea of a pod. The pod consists of connection servers, right? And so what's going to happen is the pod is nothing more than a cluster, a bunch of connection servers that are all replicating with each other. Remember the little shared database? Okay. Each server is capable of managing 2,000 concurrent connections. Now, what's wrong with my statement a minute ago? I said this would support 2,000, but I had 2 connection servers, right? Okay, well, that's for redundancy. That's n plus 1. That means at any given time I can lose one and I'm still up and running. Okay. What we use for 10,000 is a recommendation of n plus 2. That means at any given time you can fail 2 of these and you're still hot. So for 10,000, that wouldn't be 5, right? 5 would be n. It would be n plus 2, so 7. Okay? So a view pod for 10,000 would be 7 connection servers, and then you'd be good to go and be able to fail 2. So what sits on top of these? On top of these, we've got the view block, okay? So what that means is that every time you dump in another vCenter server, that vCenter server is kind of the point of demarcation with the block. So if you've got, so in this example, each one of these view blocks, what we're going to be doing is we're going to be wanting to put, 2,000, concurrent connections in each one, because if we have 2,000 in this one and 2 in that and 2 in that, etc., then we're going to have 10,000 across all of these, right? So every time we have this, we're going to put in another vCenter server. And that vCenter server owns that group. And that vCenter server is spoken to by these connection servers. Okay? Et cetera, et cetera. Okay, so what we've got so far, a pod is a group of connection servers. Each connection server can support up to 2,000 concurrent connections. A block is an instance that is marked off by each vCenter that's connected to it. So now we're going to kind of raise this up a little bit, and we're going to say, okay, if we're talking about really big scale, like 10,000 or more, right? The best practice is to kind of split out your management block. So what does that mean? What that means is this, and this is important when we're selling hardware too. Let's say, and I'm just going to kind of scribble right here on the top of everything, so forgive me. Let's say you got a customer and they've got a cluster of some physical servers, all right? So international symbols for physical servers. So they've got those, and that's what's running their server workload. But now they want to do view. Well, what they're going to do is they're going to buy more physical systems to use as hosts. And what they're going to assign this as is they're going to say all of the management bits, all right? Let's keep that over here with the server workload. So like all of the vCenters and the connection servers, let's put those over here, right? And let's take all the desktops that are going to be floating around out here in the ether, and let's assign them to these server resources. What that does is that means that if there's an issue on the management side, that doesn't impact the user's resources. And if there's an issue on the user's resources side, that doesn't impact management. So it's just a very clean way of keeping things, tidy, right? And it's not complex. I mean, and if you think about it, if any of you have ever seen a vSphere infrastructure, it just means, okay, I'm going to put all my vCenters over here on these clusters, and I'm going to put all my desktops over here on these. It's pretty straightforward stuff. So now we fill in the rest of this image. And now we've got the vCenter blocks. So inside of that, what that vCenter is controlling, vCenter sees some storage. Okay, that's cool. It sees its ESXi hosts, right? Remember those that we talked about a second ago, the ones that the desktops are living on? Because the vCenter doesn't live on those. The vCenter lives over in the server provisioned cluster. And then those ESXi hosts are going to be used to create your desktop pools. And the pools are literally just groups, bundles, and bunches of desktops that get provisioned. Nothing more. Okay, any questions so far? Okay. So now we've got a block that contains the hosts and the storage to provision the virtual machines. We've got the management block that contains all of the vCenters and the view connection servers. Each view connection server can support up to 2,000. But we did n plus 2, that gives us 10,000, right, for a total of 7. And we've got each vCenter block supporting 2,000 in this case, right, to keep it even. And we've split them up. Each vCenter block has a group of resources that it's assigned to. Okay. The last in this image kind of takes it all full circle. So we've got about 2,000 users across each one of these that can access these virtual infrastructure clusters. That's what VI cluster means here, right? So basically a cluster of hosts. And it can access the view desktop pools. We're not going to get into the local mode thing because this right here, this idea is where Horizon Flex comes in, right? So we're not doing that anymore. And also these transfer servers, we can forget about those. Those don't exist in this world anymore. So we've got users accessing pools on top of ESXi hosts that are controlled by a vCenter. That vCenter is being accessed by the connection server. The connection server is what says, make me a machine. Right? And then the security servers are there, remember again, because they listen for 2 and they transmit on 5. Right? They're there to keep everything nice and tidy and secure for people connecting from the internet. So if we look at this, like I said, again, this isn't a complex architecture. Now, what happens when you have 9,000, 9,200, or you have 6,100? Okay, well, that's where you just kind of have to step away and go, all right, this is the time that we need to get into architecture. You've got 25,000 or whatever it is. The idea here, like I said, for everyone on the call, even those of you that aren't engineers, is to say you understand why our architecture is different. You understand the simplicity of our architecture and what we're capable of at a small level and a big level. So if we look at this, right, and I'm going to go back like that so it's a little cleaner. If we look at this, high level again, pods consist of up to 5 blocks, total of 10,000 machines, best practice at 2,000, et cetera, et cetera. You keep things separate whenever feasible. And when we move up to version 6, we're seeing a lot of new field IP coming in with some new best practices. So kind of stay tuned for that. We don't have those all fully vetted out just yet, but we're going to see more and more of that content as we move through. The one thing that we mentioned here too is the presence of a composer. Now the composer is what takes care of the linked clones. Other technologies, Citrix uses PVS, okay? Very similar type of thing, just different in its actual execution, okay? So what we're going to do now is we're going to take a look at the actual calculations that come into play, and this is something that everyone theoretically could leverage over the phone just to kind of get them close. And you'll see why it's important here in a minute. So here's some fundamental sizing. So let's start over here on the left-hand side. You start by asking a very simple question. How many desktops do you want to do? You can do 500, 1,000, 2,000, 10,000? How many do you want to do? And how much memory per desktop do you need? Okay, well, that's a big question, isn't it? The customer's probably going to go, I don't know. This is why you come back and say, okay, well, we can do an assessment to help determine exactly what you need, but what are you doing for desktops right now? Get them close, right? A swag. And they'll say, 2 gigs, 4 gigs, whatever. If they have a bunch of developers, they'll probably say 10 gigs a machine. They never use. So you take those two numbers together, multiply them, and that gives you the required memory. It's simple math, right? You need 500 desktops at 4 gigs apiece. 5 times 4 is 20, so you need 2,000 gigs of memory. Okay, that's pretty simple. Now, how do we determine how many physical systems we need? Okay, now we're getting into the meat of it. What's your physical memory per host? How much do you have? This question right here is one that should be asked to the customer. How much density are you comfortable with? Right? What are you comfortable with doing? They may come back and say, I don't know. Say, okay, well, here's what I mean. Are you comfortable with running these machines up to 100%? That means one of them fails and you're toast? No. Okay. Do you want to just run them down at 50% of what they're capable of, so that you always have you're basically wasting 50% of your resources? Well, no. Okay. Well, what's the number? What's the percentage? They'll probably come up with something like 80, 90, 75, something in there. Okay. So you just take that number. Now, the reason I say always ask the customer is because it's infinitely easier. If you go in there trying to do the math forward, it'll take hours, right, of trying to dial it in. It's easier to do this, plus it puts the onus on, where they are. So you take the physical RAM. Let's say you've got, 96 gigs, right, and they want to run them at 90%. Well, that's going to mean we're going to have, 80 some odd gigs of actual available. So basically whatever's there, multiply it by, what they're comfortable with losing, and that gives you how much you can actually work with. So now you've got the total memory you need and the total per host. So now it's just simple division. That'll tell you how many hosts are required, and then you divide that by how many hosts you want to put into a cluster, which is determined upon the type of storage you want to do. And it could be anything from 8 to 32, right? You guys have heard stuff about like vSAN, right? vSAN could support like 32 hosts in a cluster. Some other storage only supports like, 8 hosts in a cluster is the best practice. So then that tells you how many clusters you need. So really, you asked 4 questions. That's it. You asked 4 questions, and you were able to determine how many hosts they're going to need and how many clusters that's going to be in. And because we had the cluster conversation, you're able to start making some recommendations about storage. All because you asked 4 questions. Now, for me, that seems really, really cool. To be able to take very simple data and turn it into something like complex and useful to the customer. So what does this look like? Okay, so we got 500 virtual machines, 4 gigs apiece. That's 2,000 gigs, like we said. We're going to buy a server. Each one of the servers that we're going to buy is 96 gigs apiece. We can run them at 90%. That gives us 86 gigs actual usable. Take 2,000, divide by 86. That means we need 23 hosts. So we're going to round up and divide that by 8 hosts per cluster because we're not doing vSAN. We're just doing like some basic storage. So what I know is I ask those 4 questions, and I can come back and tell the customer, okay, you're going to need about 24 machines, 24 physical servers, and they're going to be spread out into 3 different clusters with the kind of storage that you're using. There you go. Now, in practice, is it always that easy, that clean? Not exactly. And we do have calculators. There's tons of stuff out there. But this is kind of like, scratch on the napkin, or if you're out doing a whiteboard, to be able to, communicate this, right out of the gate, and to be able to walk them through their ideas so that you're getting closer. So now we go on to, kind of the basics of storage. Right? So storage basics, well, pretty simple, right? How many users do you have? And how big is the disk per user, right? How much data do the users store? That tells you how much the users require. So example, we've got these 500 users. 500 users, they have, maybe, 1 gig of storage, right? So 500 users, that means you need 500 gigs, right? You multiply that by 7. They each have 7 gigs they need. You need, 3,500 gigs for, all 500 users. So this is basic math. Then you have the desktops themselves. How many desktops? Well, we had 500. How big are the disks per desktop? So we got to include those. You got operating systems and all that good stuff. So maybe you've got 500 desktops, and each desktop is going to have, maybe 40 gigs, right? So now you're looking at 500 by 40, right? That's a lot of storage. Okay, so you guys have heard this before. Customers say, well, we're interested in doing virtual desktop, but, okay, and I heard a really smart guy tell me, he says, the word but is an eraser word. Everything that they said before that word now doesn't matter. Okay? Because what they're about to tell you next is what they really mean. So we're really interested in VDI. We'd love to do it with you, but we're really concerned about the cost of storage. Okay, I'm sure that someone on this phone call has heard that. The reason they're concerned about the cost of storage is because they did this math down here at the bottom. They said, I need all of this for my users, and I need all of this for the desktops. That's a lot of storage. This is where something like using linked clones can reduce that significantly, right? On average, my experience has been somewhere around 28 to 32%, give or take. Some of the papers, some of the marketing stuff says 50% for us, or 50% for PVS with Zen or whatever it is. I've never been able to make any of that math work on either side of the fence. I think it's usually about 30. Okay, and so you wouldn't even have to know how to do this next part if you knew this and said, okay, well, this is all the storage you'd need if you did it this way, kind of, fully born, fully hydrated. They come back and say, okay, well, that's too fat. I can't do that. Okay, well, if you decide to go with linked clones, we can shave probably about 30% off the top of that. There you go, right? You can leave it to the architect to do the rest of the math. But just in case you're interested, I have pulled together one of the coolest formulas that I was ever able to snatch out of anybody's paws. This is actually the calculation used to do linked clones. This is it. So, if you want to take a screenshot of it, this is a good one. So the idea is this. We take the total number of virtual machines, right, per LUN, and this is, again, a best practice thing, get anywhere from 64 to 128 based upon what we want to do. And a LUN is just, one identification inside of a storage array for those that aren't familiar. And we're going to multiply that by the sum of the delta, which is the virtual machine RAM times 3, plus the log file, which is usually like 0.1 gigs or 100 megabits, plus if there's any persistent disk, like a disk that needs to be there, whatever happens to the clone, right? Plus the disposable disk, which is equal to the virtual machine RAM. So you can see a lot of this is based upon how much RAM is required, isn't it? So all the more reason that first question, or actually question number 2, right? How much RAM do these machines need? That's an important question, right? And that's why we keep talking about assessment. Because if this number is fat or skinny, all this math goes right out the window, just because of that one single-digit number. So then we take all that, and we add on a replica and a master replica. So what does that mean? Well, what that means is that the master replica is like the golden image of that desktop. The perfect, fully installed, everything's perfect, just, man, that's the one. Okay. The replica is about 20% lighter than that, and that is put across all of the storage, and that allows the clones to get their connection to kind of their own master copy. And this also keeps you from having like single points of failure. And then we throw in a little buffer just for the sake of being funny. So what does this look like if we actually did math? So we've got our 4 gig virtual machine, and we decided we were going to do 64 VMs per LUN. Really, that's all we need to know, okay, for the most part. So we got 64 virtual machines per LUN, right? We've got, and then we've got our total of, our log file, our persistent disk, our overhead, and our deltas. And then we've got, we said that, the master copy is maybe a 30 gig machine, right, the golden one. And so each one of the little replicas is about 24, and then we put in a buffer. So the total of all those gives us about 16.1 gigs. We multiply that by 64 virtual machines, because remember, we're just focusing on what we're going to do per storage unit. That gives us about 1,030 gigs. Then we take the total of all of the masters and all that stuff. That gives us about 208 gigs. And then what we're able to do is we're able to say you multiply the complete number by the number of LUNs you're using, right? So you take 1,030 plus 208, and you multiply that by how many LUNs you're doing, gives you the total number of LUNs required. So what does this mean? What have we told the customer at this point? The customer called up and they said, I want to buy some VDI. You said, how many desktops and how big is each desktop? And how big are these physical servers that we want to buy? And that could be anything that's in your arsenal. Now you can make a solid recommendation about the size of the virtual server, can't you? Because you know what that's going to impact. You know about how many you can squeeze on there. So you asked them some pertinent questions. You said you're going to need about this many. Then you took and said, okay, we know this information. Now let's, we can take a conservative approach and take a swag at what you're going to do for storage. I mean, hopefully you're all looking at this and going, I'm becoming more dangerous. And you should be, because you are. Now when you get into virtual desktop conversations, you're able to say, okay, this is about how much compute you're going to need, and if you go with the linked clones, right, which, remember, shaves off about 30%, and you can kind of see why, that you're going to save about X amount of storage. Now you could just stop there, just shave off the 30% and move on, right? Or if they said, well, I want to get my storage guy on the phone. Okay, well, fine. It's going to be then in the hands of an architect or an engineer, as it should be, and that's fine. But it's really great to be able to follow along in the conversation when they come up and say, okay, this is what we're going to do, and it's going to be spread across this many LUNs. What just happened is the customer's walking away knowing what I need to buy, what I need to provision, what my storage people need to know about, and you're going further toward being that trusted advisor inside of space so that you're creating kind of a predictable sale. So now, moving off of the calculations, what do I do with my applications? This has kind of been the bane of architecture for a long time. How do I do this? Well, my preference has always been to follow the use case. And a lot of people, have probably heard me say this before, the use case drives the technology and not the other way around. So, all right, so use case drives technology. So what we do is we say, okay, let's say this is the executive team, and this is maybe accounting, and this is finance. Okay. So now we've got use case one. Inside of use case one, they have pretty much all this stuff, right? I mean, it's pretty straightforward. But we noticed that something like Firefox, well, man, that's deployed every single time on every desktop. So what would be the most efficient thing for me to do? Should I be streaming that and making all sorts of complicated ways for people to get that? Probably not. Probably just install it on the desktop itself. The same for, something like, Adobe Reader, right? But when I've got like some of the weird stuff, like Photoshop, only appears here and there. These are the things that you can make decisions about how these get deployed. This is when the conversation turns around to things like RDSH, like Horizon Streaming, or ThinApp, or whatever. This is when you get into those conversations to determine what is it that's actually going to be the most effective way for people to access this data. And we've got lots of ways to do it. It could be ThinApp, could be RDSH, and I've included a little, a baseline for you down here inside of the RDSH space, which is pretty straightforward, which is, you basically take your server, right, and then you're going to look at approximately 150 concurrent streams per host, so 150 people actively accessing applications. Why is this important inside of the non-technical part of the sale? Okay, very simply, because it allows you to drive this message, which is assess, assess, assess. Remember, how much RAM it needs to be in the machine? What kind of applications are you installing? This drives services. It drives the need to complete the assessment. Like I said, I know we've got a broad range of people on the call, and like I said, I mean, no bones about the fact this was a proper 301. But even for the least technical amongst us, we should walk away understanding that those initial questions we ask have massive repercussions. And so that we need to position ourselves correctly when we're talking about virtual desktop. And that's going to make you the most dangerous person on the block, more so than your nearest competitor. Now, they've created it. We've got some really cool tools that they can add on to. Things like the VMware operating system optimization tool. Basically, it just says you create a VM, whatever you want to use is the one for all the desktops, and you can point this at it, and it will say, this is the best practice, you should turn this on, turn this off, and that desktop will be just dandy. And then they can point it at it, and then they can do it again, And this tool is also going to be available for server systems, so you'll be able to optimize those as well. And this is fantastic. You know, we used to just use a script, or we used to just do it manually according to a white paper. But with this, they just, you know, kind of grip it and rip it, and the thing takes care of itself. So this is another thing to mention to customers. Doesn't cost them a penny, but it puts you inside of that trusted advisor status again. Now, the last thing I wanted to mention today, and then I'll open it up to questions, and hopefully there are some, is, you know, we were talking about protocols. How it's so easy just to say, well, VMware's better, and, well, our architecture is easier, and ours is easier to install. And, I mean, I think we know now, after seeing this, that it's not that our stuff is really that easy. It's just, it's not quite as complex, you know, from a scale perspective. It's still very detailed, and there's a lot of moving parts. But, you know, if we looked at it comparatively to some of the other technologies, it's pretty straightforward. But let's look at the actual technical differences. And I believe that one of the big ones is protocol. So if we look at that, the difference that protocols make, and we talked about PC over IP. We talked about out there in the Zen world, they use a protocol called HDX. Okay, and then for years we've all used RDP, right? It even became a verb. We say you'd RDP into a host, right? And so this is what they mean. Okay, interesting fact. RDP was actually kind of stolen originally from the old ICA protocol years and years ago. What it does is it does kind of a screen scrape, kind of per page. So when you're looking at like RDP sessions, that's why you'll get like the whole screen to kind of flicker sometimes. And because it's a TCP protocol, which means it's only controlled by the transmission itself, right? Users can't tweak it. That you can't really tune it. Okay, you can't give it, levels of optimization and that sort of thing. And it kind of takes a best effort approach. It does the best that it can. It doesn't really do a lot of counting or anything. It just kind of does the best that it can, and that's why, connections will get dropped all the time, and you get, sometimes kind of fuzzy bits in the screen and that sort of thing. HDX is also a TCP protocol. Why? But it is it kind of takes a perfect effort approach. So what does this mean for HDX? What does it mean that people need to consider when they're talking about using an HDX protocol? Well, quite simply, it means that let's say over here you have the data center A, where everything is located. And over here you have, the remote office, where, all of the desktops need to be. And let's say this is a huge geographic distance. The problem is that when that desktop request gets made, and keep in mind that it keeps getting made over and over again, because every time they change something, it's changing something back at the data center. TCP says, I'm going to count all of what are called the header packets, right? So basically, it's going to enumerate all of the bits about that transmission. And let's say, it sends over, it gets a request, for, 15, and it only comes back with 14. Well, what happens? It says, something went wrong. Terminate. You got to start all over again, because it's perfect effort. So people get a lost connection. This is why with these technologies, they've got these ideas of what are called branch repeaters. I think they call them something else now. It's called like a cloud gateway or something like this. And what that does is that bolsters the power of that connection to try to make sure that these numbers are the same as they transmit their way across space and time. So having that non-tunable perfect effort kind of thing is really good as long as you're not leaving the building. I did a review for a really big architecture like that, and man, inside of their building or their two buildings on that street, everybody's like, "This is amazing! This is the best! It's the fastest! It's the coolest thing ever!" But they had people in Spain and India that were just, it was miserable. Why? Because they didn't have the repetition set up for that. So why is PC over IP different? Why is VMware's choice different? Because we use TCP, right, to count what's coming into us, but we only use UDP in the other direction. And what's the difference? UDP is a user-defined protocol. Think of things like VoIP, voice over IP, right? That's also a user-defined protocol. And so the exciting bit with that is that you can tune it. You can give it priority inside of the data center. And because it's really best effort, not perfect effort, if the customer sees or the user sees maybe a little flicker in one character on their screen, we're not going to terminate the connection. We're going to go, okay, that's fine. We'll just keep sending. Right? We're going to do the very best we can for as long as we can. So that makes PC over IP an awesome choice for things like internet access. So now instead of just being someone that says VMware is awesome, this is why, right? Because our stuff is simple and our stuff, our colors are cooler than everybody else's. It's about this is why our technology is inherently different. It's right down to the architecture. The architectures are not created equal. We've made some very specific decisions for some very specific reasons. That makes what we do a little more lightweight, and it also makes it very repeatable, and it also makes it very, very scalable. So with that, I'm going to say thank you guys for taking the time